To good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to this Techstrong Learning Experience brought to you by Revenera. My name is Cody, and I'm the host of Techstrong Learning, and we have an exciting presentation ahead. First, I do have just a couple of housekeeping notes to cover. Today's session is being recorded, so if you miss any of our discussion, or perhaps you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live session today. If you look to the right side of your screen, you'll see there are a couple of options to engage with our panel today. The first option is the chat tab. So I'd like you to go ahead and start chatting us up right now by letting us know from where you are tuning in. Right next to that chat tab, you'll see it says Q&A. If you have questions, we'd like you to direct them there. However, if they end up in the chat tab, we will still address them. If you jump over to that handouts tab, you'll see there are a whole lot of resources that have been uploaded for you. So please do take advantage and grab as many of those as you can. And of course, before we close out, we are giving away 4 $25 Amazon gift cards. So the topic of our program today is breaking through the SBOM noise, a no-nonsense guide. And I'm joined today by Alex Ryback, Senior Director of Product Management at Revenera, and Dr. Chris Wood, CISSP at Lockheed Martin. So Chris and Dr. Wood, thank you both so much for joining me today. Alex, would you like to go ahead and open us up?
Yep, absolutely. Thank you, Cody. Thanks, everybody, for joining us today. So we got a pretty good session for you today. Lots of different topics we're going to be covering. You can look through them on the right. But basically what we are going to do is we're going to start with a little bit of background on the chance that somebody is new to the world of SBOMs out of our attendees. So we'll cover a little background of where they came from, what's really driving the need for SBOMs. We'll talk about the different formats that are available, give you a quick update on the latest regulations around the world, as well as the United States. And then get into a few examples. So we'll show some SBOMs, call out the different elements inside there, and give you some context into how various documents across SBOMs and security documents relate to each other. And then we'll go through some best practices around how to build them, who needs to do that, and what do you do with them once you receive them. So let's get going. Okay, so first of all, I really want to spend a few minutes here and kind of lay out why do you need an SBOM and what is the actual industry problem. So as we all know, the way that software is built over the last few decades has changed significantly. It used to be that your company, either the development team in your company, did all the work. They wrote all their code. Once in a while, you maybe brought some third-party content in, but typically it was through a commercial agreement. It was managed. There was lots of visibility to it, and it was a fairly kind of rare event. If you look at the way software is done today, it is done by pulling in lots of open source content. We typically see on an average application up to 80%, sometimes more content that is not created by your development team, which is great, right? You're not spending time implementing constrained functionality. You're instead innovating and writing your own kind of secret sauce and features that are valuable to your customers. But a big chunk of your product has risk. And none of that is a bad thing. It's great. It just needs to be managed like any other corporate risk. So why is open source a challenge? So if you look here, there's several diamonds on the screen that depict elements of a product. So there's commercial packages. Perhaps you OEM something. Perhaps you've got a database you call into. There's lots of proprietary code. This is kind of all the stuff that your team writes. But then there are various open source components. And the challenge becomes that each of these diamonds in turn also contain open source. And then if you look inside open source packages, then they contain other open source. So the whole kind of point of this is lots of reusability, small building blocks, and lots of nesting of third-party content from various authors around the world. Furthermore, often what we'll see is within proprietary code, there's also snippets of code. So perhaps a developer went to a blog, perhaps they used a helper site, somebody offered up an option on how to implement a certain function, and that code gets copied in. So the challenge to all this is managing all of that. If you look at the way software is typically sourced from a proprietary perspective, it is sourced through buyers. It's sourced by having a relationship with a company that you buy from. In open source world, it's sourced by developers. It's more of a bottom-up view. And typically there's a lot less eyeballs on that transaction, and the volume is much higher. So it needs a different approach. And the challenge is that since there's so many of these pieces, when you sell your software to your customers or your partners who then sell it to their customers, there's lots of visibility and transparency challenges unless all of these parts are cataloged. So I always like to kind of show this graphic because this is kind of the real world, right? You spend all this money on infrastructure, invest a lot into testing, invest a lot into your developers and their level of quality and their knowledge over time, and then you've got this little esoteric component sitting at the bottom that is developed by somebody out in the universe, right? We typically don't know the developers from whom we're grabbing code, and if something goes wrong, everything kind of comes crumbling down. And we've had two examples of this in the past few years. Everybody's by now aware of the Log4j event, where a very popular, essentially anyone who uses Java likely had Log4j being used for logging functionality. And there are 3 developers that maintained Log4j. And this component ended up being in millions of software packages, affected pretty much every company out in late 2021. And these 3 developers were on the hot seat to quickly produce a solution to the problem. The challenge is these developers have full-time jobs, they have families, they have obligations. Their job is not maintaining this. This became, started as a hobby and then suddenly gained tons of adoption. So the challenge is you've got lots of companies, lots of users now essentially dependent on 3 individuals who never really signed up, for the challenge here. Second example is, if you go back to 2016, there was a little component on NPM called left pad, which just padded some text on the left side, which ended up being in tons of people's dependencies. And when the developer accidentally removed some code and subsequently a component was taken down, suddenly lots of builds started breaking. Right. So all of these are kind of 2 innocuous components. These are ones that nobody was really concerned about until suddenly the fact that they're dependent on them caused problems. Right. So there's a couple of links on the left here. You can read about it. Especially the Log4j one's a really good article on kind of the human toll of having to maintain an open source project when something goes wrong.
Yeah, I think the real sad part about that whole deal is how much Log4j shell is still out there in the world that people haven't even tried to remediate.
Yep, absolutely. And that's a really good point. Whenever there are quality issues with a component, typically overwhelmed by a security issue, it has a very long tail. It's rare where the fix is complete in one patch. So therefore, you have to kind of stay on it and continue patching until it's completely eradicated. But even more importantly is people kind of forget about it. So, we had Heartbleed, we had Apache Struts 2 vulnerability that led to the Equifax breach, and all of them were critically important at a point in time. And then a few months down the road, after 100 others, people forget and you stop looking for it. And it'll come back and bite you. And we always see it, to Chris's point, whenever we do audits at Revenera, we always see old OpenSSL, old zlibs, old Apache components that are still vulnerable, very well publicized, very well, very much talked about, but they have not been eradicated. They sit around until they end up being exploited. So important to not forget to look back after an event has concluded in the news. So the other thing that's really important to understand is why the supply chain is important to the conversation of SBOMs, to set the context. So I always like to bring this comparison between the hardware and the software supply chain because there's a lot of similarities there. So on the left side, you see a complex product, so an airplane, right? This is a Boeing airplane, and it obviously consists of millions of different parts. So there are suppliers from all over the world. Clearly, none of these suppliers are a surprise, right? They're all carefully selected. They bid for the project. They go through lots of different quality checks. All the different materials that come into Boeing, who ultimately assembles the plane, go through lots of scrutiny, lots of testing post-assembly. And if anything ever goes wrong, the entire provenance of every single part can be unwound back to the original manufacturer. Then it's compared to the specification on quality that was established when the relationship came to be. And that part is remediated. And then either quality checks are updated or perhaps vendors are swapped out. If you look on the right side, when we look at software, well, software also consists of thousands of parts. The challenge is that the software is not sourced in that way like hardware, right? We don't speak to the developers that maintain it. We have a developer make a decision to pull something in, and then hopefully there's a process in place to vet the items that are coming in. But the complexity is similar. You've got subcomponents in software. Subcomponents have open source. Every open source component likely has other open source inside of it. So the complexity of the two is very similar. The other thing that's important to note is typically there's a very small percentage of the parts that the actual manufacturer or the software producer creates on their own. So as I mentioned earlier, on the software side, we typically see around 80% that is not, that's first-party software created by the company. If you look at the Boeing airplane, Boeing builds the tail fin, they build the rear fuselage, they build the fairings to attach the wings, and then they glue everything together. Everything else is built by somebody else. So again, if there's a problem, Boeing needs to quickly figure out their logos on the plane. They're the ones that are going to get the call. Who manufactured this part? Who put the subassembly together? And who installed it into the airplane? On average, we see about 2,500 parts per audit when we look at products from a services perspective, which is about a 9% increase from 2021 to 2022. So lots of parts in play, and they need to be managed just like you would with hardware. The other really important thing to note is hardware supply chain is a really mature technology. There's lots of tooling out there. There's lots of processes. It's been happening for decades. Software is immature. And right now, all the efforts around the software bill of material are to contribute to the maturity of the software supply chain, greater transparency, greater provenance visibility, and understanding how to quickly remediate parts and kind of be on top of compliance issues.
Right. So when you're building your bill of materials to deliver to the customer with say for example, a car, an airplane, or a train, tank, whatever it happens to be. In the old days, it was all run through the factory, and all the information was collected during the build, and there wasn't ever any consideration for the software components that actually made up parts of part of the construction of avionic systems, for example, in an airplane, and other than the version number of the radio itself. So the problem now is, how do we incorporate the software bill of material or the firmware bill of material over into the hardware bill of material, so that when the customer gets their product, they've actually got a complete package of everything, the provenance and pedigree, if you will, of the software that goes into the hardware, what hardware it's in, and so forth, so that it becomes a complete package.
Yep, really,
So
really important point, because there's hardware, there's software, there's the platform in which you're deployed, there's an operational perspective, there's cloud services you rely on. So today we're focusing on SBOMs, but you'll see throughout the webinar we're going to talk about this concept of an expanded scope, because we're kind of at the beginning, right? You have to make sure that you've got a complete system view to be able to have full control. Okay, so that all brings us to the software bill of material. So let's kind of define it. So software bill of material is essentially your soup can ingredients label, right? It's a formal and a queryable record, and that's important because it has to be actionable. That gives you the details and relationships of the components used in an application or a service or a package. The software bill of material has been defined to require minimum elements. So information, for example, about who is the supplier that produced the software, who created the bill of material, what tool did they use, when did it happen, are all the parts inside of the application. So what are the components, versions, what are the unique identifiers for those parts, and probably most importantly are what are their relationships, because we don't live in a flat world. Software components are related to each other. Very often you will have a set of dependencies for your application. Your dependencies down the line have their own dependencies, which are transitive dependencies to you. These are things you typically don't request to come in, but they come in to make sure that your application functions properly. So having visibility into relationships of parts, something to make the part unique so that you're communicating about the same item with your vendors and with your customers, and having enough descriptive data there to be able to track the part with associated licensing and security information downstream is critically important. And those are kind of the bare elements that make up an SBOM, but a lot more than this is really required.
right, and I think that when the big focus on the SBOMs came out last year in the executive order, the focus was really around what you might want to call a vulnerability SBOM, if you want to call it that, because everything that they focused on had to do with security, and none of the other elements were there, other than things like what components were in there, and where did they come from. So they kind of left out the rest of the bill of materials for software itself. So I think that that's going to lead a little bit further into our discussion here. But that's an important point that you need to think about when you read the executive order and then you read the following commentary that's come out of NITA and CISA, that it seems like it's almost conflicting in some areas, or there was no coordination maybe, or they were thinking about different things that were important to them at the moment. So
Yep.
go ahead, Alex.
Okay, so Chris kind of introduced a few acronyms here. So let's talk about the ecosystem and what's really driving SBOM adoption. So on the top right, you see there's lots of acronyms described. So here's kind of the main points to take away. So number one, Chris referred to the executive order. So in May of 2021, U.S. government issued an executive order, which is essentially a paper that says we would like to accomplish the following things, broken down into various sections, each section focused on an element of the cybersecurity problem in the US government. This was not the first time, right? A lot of people kind of think that SBOM started with the executive order. We personally, in our company, have been dealing with what we call bill of materials since 2009. There's lots of industry leaders that are kind of mature in their processes around SBOMs that date back several decades, where they were dealing with what is the composition of my application. So SBOM kind of became the moniker that everybody uses going forward, but there's lots that was predated and showing up before the executive order. The other point to note that's important is there's other industries that were kind of leading the way, right? The healthcare had a language around composition of medical devices and the software on them. The automotive industry, energy, the Federal Trade Commission around consumer goods. There's lots of work that's been done in the European Union around cloud, IoT, medical devices, payment technology, telco. There's lots of language around this concept of having transparency and visibility into whatever the products that you're sending out the door or hosting. The second part to consider is process. So how do we do this? So there's an industry organization called OpenChain. It is an ISO standard. And OpenChain initially started by focusing on open source license compliance program, and recently has now expanded into security assurance standards. So OpenChain is really all about not dictating how to run a process, but think of it as a QA checklist on whatever process you're running. Is it adequate? Is it complete? Has it checked all the boxes? Is it robust? And is it improving over time? And I'll let Chris weigh in. I know he's part of the folks that worked on the specification, so I'll let him comment on this a little bit.
Yeah, I've been a part of the open chain process now for several years, along with other industry members from around the world, uh, and from automotive manufacturers to electronics manufacturers to washing machine manufacturers. We've all participated in the development of the open chains specification that talked about how you do open source compliance in general. And at the same time, the Linux Foundation was working on the SPDX, which I'm sure many of you are familiar with, as a short term to explain exactly which license you were referring to in the software. And then recently, in the last 2 years, we've been working on the security assurance standards, again, from an international collaboration standpoint.
Yep. So if your company is not involved with OpenChain, highly recommend you go to their website, check out material. They've got lots of great learning content for your product teams, legal and security teams. And they've got a really easy way to become conformant by providing kind of all the steps you have to go through to make sure that you've got a robust and transparent process of managing your third-party content. So Chris mentioned SPDX, right? That's one of the predominant formats. SPDX dates back to over a decade ago. It was really designed as a format to communicate licensing from a bottom-up view. So it is more around for every single file in your application, what is the driving license for that component? And SPDX has been around for a while. It is in the middle of coming up with a new specification that's going to be significantly different. So look out for that. That's supposed to happen later this year. The second format to know about is Cyclone DX. This one dates back to 2017. It is on version 1.4 with a couple more planned later this year. And it is really had more of a security focus. So this is more of a top-down view, which gives you a component view, not so much a file level up view. And it is really designed to be very flexible to accommodate not just software bill of material parts, but also things around cloud, things around hardware, things around operational elements within your deployment. And we'll talk about that a little bit more later. But two different perspectives, kind of one bottom up, one top down. We'll talk about how do you go about selecting one or which one is better for your context. But there are lots of tools around to convert from one to the other. So there should not be concerns that if you opt into one or the other, that you're necessarily stuck with it forever. They're compatible. They ultimately have common data models, and there's a way to move from one to the other. Okay. Another important thing to understand is this is not just US led. This is a global movement. Cybersecurity is a global problem. Cybersecurity, every cyber attack has potential of foreign actors being involved. So it's important to understand that it's not just US that is leading the charge. Like I mentioned, there's multiple legislation making its way through in the European Union. There's an EU Cyber Resilience Act that talks about bill of materials and talks about cybersecurity. There's regulations around secure supply chains for IoT devices, for cloud services schemes, for PCI security frameworks. So lots of different industries and countries involved in the movement. And clearly, medical devices has had language around software bill of material for a very long time. So given that, let's kind of talk about what has happened in the US. And there's kind of three main things that we really want to talk about. So the first thing is in May of 2021, an executive order was issued by the US government with the intent to improve the nation's cybersecurity. The executive order essentially deputized two government agencies to go away for about a year and a half and do work, right? First was NIST, which is the National Institute of Standards and Technology. They're part of the US Department of Commerce. And their job was to go away, assess the various sections in the executive order, and come up with recommendations, best practices, standards, tooling, and guidelines for the industry. Now, this was done with lots of participation in both private and public sector. And this was done with lots of different companies writing position papers, offering opinions, and really collaborating to make sure that there is a great set of input to come up with standards and best practices. Once that concluded, CISA has taken over on really operationalizing the guidelines that were set by NIST and has taken over the responsibility going forward of further updating SBOM requirements. The next thing that occurred is September of last year, there was a memo issued by the Office of the President with guidelines that, first of all, stated that NIST guidelines have to be followed by the federal agencies within 24 months, starting from last September. And there are really two really important dates set out. So date one, which is 3/4 of a year after September, coming up on June 11th, was everything that is deemed to be critical software in the federal government needs to start collecting attestations from the vendors that provide the software. So essentially, they need to have a bill of material. They need to have corresponding security reports to identify what to focus on, and an attestation that is basically a statement by the vendor that their data is trustworthy and that they have followed best practices. And then a quarter later in mid-September, same thing holds for all software. So not just critical software, but all software used by the government. So two important dates to note. If you happen to work for a company that does business with the federal government, with the military, just keep in mind that they will likely be calling and requesting this information. So good time to start getting into the process of producing these artifacts. The other thing to note is the OMB and CISA are working on a common form to help agencies with software self-attestation. And the date for that is coming up soon as well. And then the third thing that was significant is on March 2nd, the White House published the National Cybersecurity Strategy, which is kind of the next level of maturity beyond the executive order, which went from we would like to do the following to we now have a strategic focus on accomplishing the following goals. It was laid out in a kind of a multi-pillar document. And ultimately, one of the big kind of elements of the strategy is to really shift a lot more burden to the software producer. So there will be conversations around liability, who's responsible if there's a breach, what is the standard of care, standard of duty. So we'll talk a little bit about kind of what this means to people, but definitely something to keep an eye out on. Right, it's the beginnings of the conversation. There's got to be legislation that comes out of it to make these hard regulations, but this is kind of the next step of evolution, and kind of look forward to additional updates going forward.
Yeah, I think in addition, and in support of what Alex just said about OMB and CISA developing a common forum, is CISA just announced in the last couple of days that they were going to begin scanning all of the critical infrastructure in the government. Now, what all means and what they consider to be uh, critical is not defined, but that means that they're going to be going on a massive scanning run to make sure that everything is in order there. And I assume that they're going to be presenting to themselves anyway, SBOMs coming out of that. At least I would hope they would, since they seem to want them from us.
Yep. And there was a question around, does executive order talk about private companies not selling to the government? So no, the focus of the executive order is business with the government. However, typically, so if you think about it, the government is the largest purchaser of software, the largest user of open source, and carries the largest budget. So they're going to lead the way. Clearly, this will make it into private sector as well. So even if you don't sell to the government, you likely sell to customers that perhaps then sell to the government or sell to other nations. This may end up being part of just doing business worldwide. So even if you're not selling to the government, definitely something worth paying attention to and just getting ahead of it, because this will permeate into the private sector as well.
Yep.
Okay, so let's kind of move on and spend some time on some best practices. So we talked about kind of what are the minimum elements in the software bill of material, which is great, right? That's enough to kind of qualify that yes, your SBOM kind of fits the bill. But let's talk about what it really needs to have to be useful. So clearly, the bill of material needs to have header information. So who built it? What organization do you represent? What application does this bill of material represent, or what element of an application or environment or a hardware device where the software is going to go does it represent? What tool was used to create it? This is important. There are dozens, if not hundreds, of SBOM generators out there. It is impossible to hold everybody to the fire and make sure that they're all conformant. So it's really important to understand which tools are more trustworthy, less trustworthy. They all attempt to conform with a spec, but again, the spec, there's kind of lots of variability on how you comply with a specification. So it's important to know who the source is, who did it, when they did it, and what tool they used. That way you can kind of assess your level of trustworthiness for that source. The next thing is your bill of material needs to have all the parts in it, right? And this is one that's difficult, right? It is really difficult if you're doing this for the first time to build a complete and accurate bill of material. This needs to have all open source, all third party, all commercial ingredients in your application. This is where things like indication of depth of analysis is important, right? If you build a software bill of material using your processes and your vendor uses their tooling and their processes, how do you know that the two are compatible, right? So you have to have discussion. You have to understand where you are in the software supply chain, who are your upstream vendors, partners, contract developers, commercial software vendors you may embed in your product. And you need to understand who are your customers, who's taking SBOMs from you, and what do they need you to provide to make their program run smoothly. So a conversation is in order to kind of understand inputs and outputs and tooling and common level of depth. And I think, Chris, you had some comments on that.
Well, I think that the important thing is that over the last few years, since we've been talking about SBOMs in a more public forum, there's been a lot of resistance, and with good reason, not to run out and create a specification without really knowing what's important to the users and to the suppliers, and before we start writing any specs. But I've recently heard several comments out in industry uh, about the need to actually start bringing a lot of these other SBOMs into the discussion and create a common high-level specification that everybody conforms to, so that the all of the disparate SBOMs that are generated can be placed and used and ingested by the tooling so that they make sense. Because right now it's very difficult to look at the inputs from some of these SBOMs and then correlate them with what you've got and combine them to provide to, say, your end customer. So I think that it's going to become important. Either the IEEE or Open Chain or the Linux Foundation, somebody needs to start working probably on a international focused high level specification that gives you the high level requirements and then lets you fill in the lower level requirements as you're building a generator to conform to the spec.
Yep. Next element is licensing. So, as Chris mentioned, kind of the original move for the government and the thing that really drove this was there's just an increase in the volume and sophistication of cyber attacks. So, a lot of the legislation that's been in place is all around cybersecurity. So, in the context of a security persona, the licensing isn't that important. What's important is which component version do I have, which vulnerabilities are there, which ones are true positives, and which ones are exploitable in my use of an application. However, the software bill of material needs to be fully descriptive of not only the component information, but also any sort of legal risks and concerns. So we get to license data. So there's typically three contexts when you talk about licenses. There are declared licenses. So what did the author state is the driving license? There's the observed licenses, and the observed licenses come from scanning or inspection, right? So when we look at the code base behind a particular component, do we see evidence of something beyond what has been declared? So maybe the package is declared under license A, but there are individual files or sample implementation or sample code under license B. So it's important to see that. And then third is the concluded license. So given, declared, and observed, what do we conclude to be the actual license, and does it correlate to the declared license? And if not, that's an indication that there may be a conflict, or perhaps the context under which you're reviewing a component is under permissive license, but there's evidence that there's something more restrictive inside there. So that's important information to pass along to legal stakeholders and to folks that deal with legal risk. Then the next thing is unique identification for each part, which is critically important, because if I'm talking about log4j from Apache and you're talking about a log4j plugin from somewhere else, they need to have either common names or something distinct about them. So there's lots of different identifiers out there. There's CPEs that come from National Vulnerability Database that essentially give you vendor product data. There are PURLs, which is package URLs, which is kind of a newer identifier, which is actually very deterministic, right? PURLs provide for an origin of where a component is sourced, along with vendor information, component version, as well as build elements such as the build targets or the operating system for which something was compiled. So it's very descriptive, has lots of elements in it, and is a great identifier to uniquely identify a part. There's lots of kind of industry discussion to try to take package URLs and add them to the public vulnerability repositories and associate with vulnerabilities for better mapping. Relationships, critically important to understand that part B is there because of part A. And the reason relationships are important is you need to know how to remediate. If you find a vulnerability in a low-level open source component, chances are the solution is not to go upgrade that component, but to go upgrade its parent for which that component is a dependency. So you need to understand the provenance and the relationship, the dependency hierarchy of why the part came into your application. That's what the relationships are for. The other thing to note is it's not just dependency relationships. There's relationships around this part is embedded inside of a binary. Maybe you have an RPM, maybe you have an executable or a DLL file. Well, there is statically compiled open source inside of that binary that is not declared as a dependency, but it's also vulnerable, making the larger component vulnerable. So many different types of relationships. Certainly dependencies are one of the more prominent ones, but important to understand that parts are related to each other, and that has to be expressed in an SBOM. And then finally is an SBOM by itself is nothing more than an ingredients list. So if you kind of correlate this to food, If you look at the label on your soup, right, and you just get a list of ingredients and you have an allergy, without understanding what allergens are part of the ingredients, you really can't take actions to protect yourself. Same thing here. Without corresponding security reports, all you have is an enumeration of parts. You don't know which of these parts are risky for you. So the VDR is a vulnerability disclosure report that effectively lists out all of the potential vulnerabilities associated with all of the parts in your bill of material. The VEX, which is a vulnerability exploitation report, is a subset of that essentially enumerates the false positives. So things that the vendor is telling you you do not need to spend time on because these vulnerabilities do not impact the product that the SBOM represents. So if you take the VDR and essentially subtract the VEX portion of it, you will end up with the list of true positives that you need to concern yourself with to make sure that they comply with your security policies. Okay, so let's look at a few examples. So here is an example of an SPDX, so a pretty basic fragment of an SPDX document. This is the tag value text format. There's also a JSON XML format. So there's multiple file formats for different SPDX and CycloneDX specifications. This happens to be tag value format. So the first thing that we see is there is an element in the header that explains the tooling, right? So what tool produced it, when it was produced, who the document name shows you who the corporation is, what the product version is. And you'll see, if you go look at 20 files, you will see 20 different variants of how this is done. The language that is used, the format that is used for creator namespace tooling. So again, important to understand and have an agreement upstream on what do you need to be able to parse this and to be able to interpret the data in here. The second part is an enumeration of packages. So in SPDX, we call them packages, and CycloneDX, they're called components. But effectively, they're talking about what is a software bill of material part that is part of your application. So you can see here, we've got a package that is Angular core. There's a version. There is a unique ID for this package inside the document, so it could be referenced to other information. There is information about where did the package come from. There then become license data in here that is optional, right? But it's part of the SPDX specification. So what is the declared license for the package? What is the concluded license? This information will depend on how this package was surfaced. What scanning technology was used? Was human assessment involved in the process? Or was it just a push button machine scan that produced the bill of material? That may have nothing beyond just the declared licenses. You can see there's a place for copyrights, right? So if there's a copyright that was detected at a package level, this goes towards intellectual property and ownership. And then there is a reference here that includes the package URL. If we go to the next element, we now have associated files. Remember, again, SPDX is a bottom-up type of report. It is a listing of all the files in your product rolled up to packages where those files are associated to. So here we've got a file. So this happens to be a package JSON manifest file. It has checksums to uniquely identify it so that you know that the file you received from the company is the same one that was assessed. And everything you see over here at a package level around licensing and copyrights is also existing at a file level. So typically what you will see at a package level will be a declared and a concluded license. And then at a file level will be licenses that are found at a file level, so the observed licenses, right? And this, again, gives you information if that is something that is of concern to you. So these files are associated to packages over here, and packages are also associated to other packages, right? So there's relationships defined in the document between packages, files, packages to packages. And this allows you to then construct a hierarchy of how parts are related to each other, along with the files that make up the parts from the assessment that was done to create the bill of material. Okay, so that's an SPDX example. Let's look at a CycloneDX example. So for CycloneDX, same thing, right? You got information up here on who the vendor is and the tooling. You've got information around the component itself. This happens to be a JSON format. Again, there's different formats there. So this gives you application information. And then below here, this is application for which the bill of material was created. And then below here is now an enumeration of components. And again, there's nested attributes for licensing as well. So similar data, just a different format, different specification, but each one has their own parsers. Each one should be ingestible into whatever tooling you are using to process SBOMs you may be receiving. So now let's focus on a VDR example. So now what we've done is we have a bill of material that lists out the parts. Each part has a unique identifier. Now what we need to know is, for a list of parts, which ones are we concerned about from a security perspective? So the VDR is an enumeration of vulnerabilities. So you can see here, there is a particular CVE over here. It has all the information about the CVE, the severity, the score, the attack vector, corresponding CWEs, description, dates, and so forth. And then the important part is there is then a set of affected targets from the bill of material. So this CVE is related to 3 different parts coming from the corresponding bill of material. Now, the reason you want to keep these separate is because your bill of material will be static from release to release, right? So unless you change your code, your components don't change. However, security documents will be changing all the time. So you typically don't want to embed security reports into your bill of material because it will immediately invalidate the accuracy of your bill of material. So you want to have a bill of material that is static release to release, and then you want to have a VDR report that is a snapshot in time of what the security exposures look like. And then the final artifact would be your VEX, which is your vulnerability exploitation. And again, this is used to allow the software vendor to declare which vulnerabilities are false positives and why. So here you can see, again, there's information about the vulnerability, similar to what was in the VDR, but there's this analysis section, which allows you to stipulate, number one, what is the state of this vulnerability? So in this case, it's not affected. What's the justification? Well, the code is not reachable. What is the vendor claiming their response to this vulnerability is? It's not going to be fixed. And why not? Well, because we don't use the component that is exposing the vulnerability, so therefore the vulnerability doesn't apply. And then you could see the target that references back to the component for which this vulnerability was reported. All right, so if you take your bill of material, you take your VDR for all the vulnerabilities, you take your VEX for all the annotations on vulnerabilities, using those documents, you can end up with a subset of parts that you deem to be risky for you as a consumer of the bill of material.
And I think that there are people who are working on automations now to automate you to be able to do that without having to have a human sit there and parse through these things.
Yep, absolutely. Yeah. As a human, so if you are getting bill of material from your suppliers, you may want to ask for a human readable version to kind of be able to parse it, right? Humans don't typically read XML, JSON, and text files very well. But this is all designed to be machine readable, standardized, and machine processed, right? So absolutely, you should not be manually sifting through and reading your bill of materials. They need to be imported into a system that will codify them, that will associate it to some sort of catalog, and we'll talk about that in a couple of slides here. So let's talk about like what is important in an SBOM. So the most critical thing is the SBOMs you receive has to be actionable, right? It's not enough to say I received an SBOM from a supplier and I'm going to save it on a disk somewhere, or save it in Dropbox or wherever, and that's it. I've done it. I checked the box and I'm happy, right? The whole point of a bill of material is this is the way that we communicate throughout the software supply chain. So bill of material gives you a format where data needs to be assessed, imported, and made actionable. So when we talk about actionable, we're really focused on 3 things. Number one, it needs to be ingestible, right? So it needs to be processed, it needs to be parsed, and it needs to be converted to something that is backed by some sort of catalog, because a bill of material item needs to be associated to a component, a version, a license, and associated vulnerability data. So that's number one. Number two, once you do that, it has to be searchable, right? You need to be able to understand if there's a new security event in the industry and there's a particular CVE or from another data source vulnerability reported, well, where do you have this issue in your organization? So you need to have an interface where you can key in a vulnerability ID and quickly reduce down to kind of your blast radius, right? Your impact. What projects, what components that I have in my product are potentially exploitable due to a specific vulnerability? Maybe there's a specific license of concern. Maybe there's a certain date of a version that's of concern, but you need to have this data be searchable. And then the most important is it needs to have alerts, right? Because today there are no vulnerabilities, or there's vulnerabilities that are suppressed because they're false positives. Tomorrow, a new one may be discovered and you don't want to be at the mercy of your supplier calling you and telling you that there's a problem. So having this tied to a catalog with some sort of alerting service for new vulnerabilities gives you indication immediately that there is a potential new security problem that needs to be assessed.
Yeah, that's why it's important that you retain your SBOM, your final SBOMs at the delivery stage for all of your products that you build, and keep them in a secure repository so that you can search them to see if if a piece of software that didn't have a vulnerability last week has now got a critical vulnerability against it this week, or one of the low risk vulnerabilities that was reported 2 months ago is now a high risk because other things have been found out. Then you need to be able to identify in which products do you now need to go and tell your customer, hey, we've got a high risk vulnerability in the product that I delivered to you last month, and here's how we suggest that we go about remediating it.
Absolutely. Okay, next thing to consider. So, what do you do with an SBOM when you get it? Again, the goal is not to just stash it somewhere and forget about it. And also, the thing to understand is this should not be a one and done, right? You should be getting an SBOM frequently from your suppliers. Ideally, you get it with each release of the software. In a cloud situation where the product is deployed as a SaaS service, it may not be feasible to produce an SBOM with every single build, so there needs to be some sort of regular cadence. But you need to have visibility into the composition of the product as it changes over time. So the first thing is you need to store it in a secure and accessible place, right? It shouldn't just be stashed somewhere in a file system. The second is you need to assess the parts for compliance against your policy, right? So what that means is even though the vendor is claiming that something may be a false positive, perhaps there's a component with licensing information along with it, you need to determine in your context for your organization, depending on how you're going to use and or package and resell that product, is it okay for you? So that's why it's critical to have both security information in a corresponding document along with full licensing information so you can bounce that against your own corporate policies. We talked about alerting. So again, it's not a one-time import. You need to track new vulnerabilities for parts that are already part of your repository and understand if there are any sort of new risks over time. We talked about continuously ingesting, but it needs to get in the habit of automatically taking updates whenever there is a new release of an SBOM from a supplier. And then you need to have an ability to assess the impact, right? Again, we're kind of getting back to this blast radius concept, but if there's a new issue reported in the industry, like what happened with Log4j, a lot of people were sitting around waiting for their software suppliers to reach out and say, my product is impacted or my product is not impacted. If you have a bill of material for their product in your system, you can get that information yourself. You don't need to wait for them to report that to you. Okay, so let's kind of talk about who needs to do this, right? And the short answer is everybody needs to do this. So anybody who is selling the software to any sort of regulated industry, public sector, government, foreign governments, right? Anyone who is essentially in that space needs to already be producing SBOMs, and more importantly, needs to be on the journey of making this part of their DNA and their company. Right? You don't want to have somebody whose manual job it is to go create SBOMs every month, right? This needs to be tied into your build system, into your CI pipelines. It needs to be part of your quality process. Just like you would not release a product without updating documentation, you should not be releasing a product without making sure that you're up to date on your build material and all the corresponding security reports. By the way, SBOMs don't solve every single problem, right? There's still open source license attribution requirements, third-party source disclosure requirements. So don't forget about these other artifacts that need to be produced. Anyone who's developing software for internal use, again, it is something that is deployed in your organization or potentially in a third-party cloud. It's still risk to your company, right? There's lots of people who only focus on things that are distributed. Well, you're forgetting about all the internal risk, right? So again, don't try to kind of boil the ocean day one and do everything across the company perfectly. But you need to have kind of a crawl, walk, run model where you're going to start with the highest risk, but your goal needs to be every single application that you are building and every single application that you are using needs to have a bill of material for you to have visibility into its risk. And don't forget about third-party applications, right? So even if you do not have a development team, let's say you're a financial institution, well, you're running a bunch of software in-house, and that software likely contains privacy data, and that software potentially could put your company at risk internally. So all of that needs to, over time, be assessed and have a corresponding bill of material to give you the transparency into the parts and security and legal risk that come from it. Okay, and then finally, kind of if we look into the crystal ball, so what's next with bills of materials? So we're kind of focusing on two things. Number one, the software bill of material needs to get richer, right? And when we talk about richer, we're talking about content and the data inside. So more information about licensing. For example, today in a bill of material, you may get a license name, MIT, right? So your license is MIT. From a legal perspective, you're fine, right? It's permissive, widely accepted, well understood. Typically, kind of nobody's concerned about it. Well, you have an obligation to produce third-party notices, which will satisfy the attribution requirement of an open source license. To do that, you need to have the actual copyright statement, the date, and the proper license text. That's typically not going to be found in a bill of material. So over time, we feel like the definition of the minimum elements will expand to recommended elements, right? So even though minimally you're compliant, really to be able to use the bill of material effectively, there needs to be additional information there. Attributions, right? So who are the authors? What are the copyright holders? You saw in the SPDX example, there's a field for that. That's not part of the minimum definition, but that's definitely information that is important and relevant to legal personas. References to where you can find the third-party source code. If you happen to be using open source under weak copyleft licenses, there may be an obligation for you to pass through the source code for those components. Well, how do you do that, right? So however you deliver or make an offer to that code, it would be great if there was a reference in the SBOM so that your consumer knew where to go to get it, right? So the goal here is to try to consolidate the number of artifacts that you have to provide to run a complete compliance program. And then finally, attestations, right? There will have to be attestations with each SBOM release, attesting to the fact that you're promising that you follow the best practice and the industry standards, and that you stand behind the quality of the documents that you're providing downstream. Right. So those, we kind of feel like all of those things right now are delivered in many different artifacts. It would be good if everything was consolidated over time into a single bill of material document that has information for all the stakeholders. And then depending on who you are receiving it, you parse out whatever is relevant to you. Okay.
And I think that's going to be one of the hardest parts, is figuring out how to do this, because the licensing for every single open source license has got different requirements for which parts of the license you need to share. And those are even friendly licenses. The notices, the disclaimers, the attributions for if they've given attributions to another author or outside party, copyright information, and the words to the license itself. So if you only provide an SBOM and it only says MIT or AGPL or GPL version 2.1, the LGPL, that's not really enough, because the license specifically says if you're going to distribute it, which is what you're generally going to do if you're producing an SBOM, then you have to actually provide a copy of that license and their attributions along with the software that you're delivering. And so it's, we're going to have to figure out from a global SBOM standard, how does everyone want to do that? What is the minimum legally accepted thing that you have to put into your SBOM in order to be compliant with the licenses, and how is it reported so that people can know which components are relying on which licenses?
Yep.
So there's a lot of questions that are going to have to be answered in order to satisfy this, and that's going to have to come with future spec work, like I mentioned before.
Yeah, and this is all fluid, right? A lot of the open source licenses were written decades ago when everything was distributed on premise. Right now, with most of the software being delivered in cloud, there will be new licensing emerging over time, and new licenses may have different obligations coming with them. So all of these things, all these activities need to be correlated and kind of grow as the needs change and as requirements change over time.
Right.
Um,
And
and
you
then
still see go ahead.
no, go.
I was just going to say, you still see licenses out there that are the very first version of a license, the GPL licenses, the Apache licenses, the Eclipse licenses. And some of those things, like Alex said, are very old, and they actually say different things in them than what you're familiar with today in that same license 4 versions later. So you really need to, you know, let the end user or the recipient know these are the requirements for this license that the author attached to this piece of software. If you want to use it, you need to understand what's in that license.
And then the second thing that we really see happening is just a broader context for greater transparency. So today's entire webinar was really focused on SBOMs, which is the software bill of material, but that doesn't cover the entire context, right? You have a SaaS BOM, right, which covers your services, your endpoints, your data flows. That's important, right? The data model is different, right? You're not talking component version license, vulnerabilities. You're talking about what are my endpoints, what are my URLs, what is my encryption algorithm, right? What technology am I using to transport data? Which direction does data flow? So these have to be expressed as well because they are also security risks, right? HBOMs, so hardware bombs, so IoT, medical devices, right? If you've got an MRI scanner, well, it's got a ton of software on it, right? It's certainly software you don't want compromised. You don't want people getting access to data inside medical systems. There's privacy concerns. So how do you express the linkage between the hardware and the software? Well, your HBOM has to tie into your SBOM, and all of that needs to have kind of an overarching product BOM that has everything in the environment. Industrial control systems, right? If you're putting software on industrial devices, also same kind of thing, right? We talk about the airplane, we talk about cars. Everything today has lots of software on it. Well, if you have visibility into all the software, it has to tie into the hardware parts that delivers the software to the user. And then
Yeah.
operational bombs, right? Runtime environments. So your product could be the most secure in the world. Well, if you're running in a non-secure environment, it doesn't matter, right? So you really have to look at this as a system security perspective and make sure that all the different elements that come into play on how your product is deployed, all of that needs to be accounted for in the different contexts that have to mature over time.
Yeah, I think two important things about that are that SBOMs are focused on the binary images. So if you're scanning a container, the scanner recognizes what the component is that's inside it, what the image came from, and it can do the security scanning real well. Licensing scanning, not so much. In fact, not at all, because the only license it's going to get is if there's a declared license that happens to reside in the information that's the metadata that surrounds the image that's within your container. And often there's multiple images within each of those containers. So you really need to think about when you're building containers or when you're using containers, where's the source code behind these images? And have we looked at those? And are they something that are free from vulnerabilities? Are they free from defective licenses that you really don't want to pass on to your consumers? For example, the AGPL license is very bad if you're going to be running a piece of software in the network world. And then HBOMs and OBOMs, really, if you think about the pipeline shutdown here in the United States last year, uh, that was exactly, they could have probably scoped that out if they'd had a HBOM and known what their weaknesses were in the industrial control systems for the pipeline.
Yep. Okay, so we got a couple of minutes left here. Thank you all again for joining. We're happy to take some questions.
Awesome. Chris and Alex, that was great. We did receive quite a few questions, but we are limited on time. So we'll try to hit some of the more broad questions first. So one issue in SBOM tools right now seems to be the lack of standards, including minimum element data fields such as supplier and version. For people using various SBOM tools, it makes the issue worse. What suggestion do you have to resolve such issues?
So I think a lot of this comes down to tooling and flexibility. So as I mentioned, there are specs for different formats, but there's lots of kind of interpretation out there across all the different generators. So you have to make sure that whatever tooling you are using for ingesting SBOMs, and there's some handouts there to lead you to some of the products that we offer, but there's lots of industry tools out there as well. They have to have a flexible data model. They have to be able to map to the fields that matter to you, even if they are different attributes across different standards. So you definitely need to get that data into the system and be able to search by it, because if there is a particular exploit out there that impacts you and it comes from a particular vendor, then you may treat that vendor differently than others. So you have to be able to trace back to who created the SBOMs, what tools did they use, how much you trust the tools, and ultimately what product that represents.
So
Yeah, I think it
go ahead.
I think it really boils down to getting a common high level specification, because you don't want to stifle innovation in the future by saying this is hard and fast, this is the spec, you're either going to comply with it or you're not compatible, and therefore you're not going to become a household name. So the specs need to be high enough to give you the what's need to be in there today, but they don't rule out adding innovation to make them better in the future.
Great. Thank you so much, Chris. So we're going to do one more question, but for all the questions that we weren't able to respond to today, we are going to be forwarding these over to our friends over at Revenera. So hopefully they can get you an answer after the webinar. So our final question here right now is, what are the existing parsers using to be able to analyze and compare SBOMs?
Yeah, there's a ton of tools out there. Again, I'll point you to the handouts for the products that we offer from Revenera, so definitely check that out. There's lots of different SBOM generators, for example, based on various ecosystems. So for NPM, for Python, for Java, there's lots of different generators. There are tools out there that allow you to import an SBOM and compare, for example, see a list of vulnerabilities associated with it. So, go to CycloneDX. They've got lots of different apps on there. If you go to SPDX community, there's lots of different tools on how to work with SPDX documents. And again, check out our website for the products that we offer. We've got a product called SBOM Insights that will do exactly that for you.
Well, awesome. Alex and Chris, thank you both so much for joining us today. I really appreciate the time that you take out of your schedules to join us on these programs. So again, thank you so much.
Absolutely.
You're welcome.
So I'd like to remind our audience that this session was recorded. So should you want to rewatch, you will be receiving an email with a link to access the recording on demand. Or of course, you can find it living on the DevOps website at devops.com/webinars, and you'll find it in the on-demand section. So the 4 winners of our $25 Amazon gift card drawing are Anjali B, Chris N, Lars B, and Stefan G. So to our 4 winners, congratulations. Keep an eye on your inbox to claim that gift card. It should be there in about the next 48 hours. But if you don't happen to see that email, please do check your spam folder just in case it gets filtered out. I'd like to thank Revenera for sponsoring our program today. And to everyone who's been here for the last hour and maybe hanging on for these extra 2 minutes, thank you so much for being here. We really value your time, and we'd like to hear your thoughts on our program today. As soon as we close out, a survey will pop up, so feel free to give us your feedback or let us know what you'd like to see on a future Techstrong Learning program. Either way, we do hope to see everyone at a future Techstrong Learning experience. Have a great rest of your day, and you may now disconnect. Alex, Chris, thank you both once more.
Thank you.
Thank you.